What if I told you that the colorful gelatin dessert sitting in your refrigerator started its journey inside animal bones and skin? It sounds unbelievable, yet every spoonful of gelatin begins with a process few people have ever seen. A process that transforms animal byproducts into one of the most versatile ingredients on Earth. Today, we are going inside the factory to discover how gelatin is really made. From raw bones and connective tissue to the bright, colorful dessert found in millions of homes. The story begins long before the factory. For thousands of years, people unknowingly used gelatin. Ancient Egyptians boiled animal bones for hours to create thick broths used in food and medicine. But modern gelatin was born in 1845, when inventor Peter Cooper patented a dry, shelf-stable version that could be stored, transported, and prepared anywhere. Over time, gelatin became much more than a dessert. Today, it is found in pharmaceutical capsules, sports supplements, cosmetics, candy, marshmallows, and countless industrial products. But all of it starts with one key ingredient: collagen. A structural protein naturally found in animal skin, bones, and connective tissues. Collagen is what gives gelatin its remarkable ability to transform from liquid to solid. It has almost no flavor, no color, no smell. Yet when mixed with hot water and cooled, it becomes firm, elastic, and glossy, a property that makes it indispensable across multiple industries. The industrial journey begins with raw materials rich in collagen: animal skins, bones, and connective tissues. Most of these materials come directly from the meat industry. What many consider waste still contains enormous value. Refrigerated trucks transport the materials to specialized processing facilities. Temperature is critical. Without constant cooling, the collagen begins to degrade. Every shipment is inspected before entering the production line. Nothing proceeds without approval. The first stage is cleaning. Powerful water systems remove fat, meat residues, and contaminants. Purity at this stage determines the quality of the final product. The cleaned skins are sliced into thin strips. The bones are crushed into small fragments, approximately 2 centimeters in size. The goal is simple: expose as much collagen as possible. The greater the surface area, the easier the extraction process becomes. The prepared materials move into massive treatment tanks. Hot water surrounds the raw materials, approximately 70 degrees Celsius, warm enough to begin breaking down collagen fibers, but gentle enough to preserve their molecular structure. Acidifying agents are added to the tanks. These solutions help weaken the protein structure and make collagen easier to release. What appears to be a simple cooking process is actually a carefully controlled combination of chemistry, temperature, and timing. The transformation has begun. Animal byproducts are slowly becoming the foundation of gelatin. Hours later, the process reaches its most important stage: collagen extraction. Massive stainless steel vessels slowly cook the prepared materials. The temperature remains tightly controlled. Too high, and the proteins become damaged. Too low, and valuable collagen remains trapped. Engineers constantly monitor every variable: temperature, acidity, pressure, time. Inside the tanks, collagen fibers gradually dissolve. A thick, protein-rich liquid begins to form. It resembles a concentrated broth, dense, cloudy, and packed with dissolved collagen. But it's far from ready. The liquid still contains fats, organic residues, and microscopic impurities. Now comes purification. The solution passes through a series of industrial filtration systems. In the most advanced facilities, ceramic microfilters remove even the smallest particles. High-pressure pumps force the liquid through microscopic channels. Only the purest collagen solution can pass through. Everything else is removed. The result is remarkable: a translucent liquid rich in collagen. Clean, pure, and ready for the next transformation. The purified collagen solution now moves toward the concentration stage. At this point, it still contains a large amount of water. Too much water. The next challenge is removing it without damaging the proteins. The solution enters enormous evaporation vessels. Here, heat carefully removes moisture while preserving the structure of the collagen. Hour after hour, water escapes as steam. The liquid becomes thicker, denser, more concentrated. What started as a translucent broth slowly transforms into a rich protein concentrate. The volume shrinks dramatically, but everything that matters remains: proteins, amino acids, and the molecular structure that will eventually become gelatin. Once the desired concentration is reached, the mixture undergoes a final thermal treatment. This step eliminates any remaining microorganisms, ensuring complete safety without compromising quality. Now the temperature begins to fall, slowly, carefully. Inside cooling chambers, something remarkable happens. The collagen molecules begin reorganizing themselves, forming an intricate three-dimensional network. The liquid starts to transform. The structure becomes firmer, more elastic, more stable. For the first time, gelatin appears in its natural form, a translucent block, flexible, glossy, and surprisingly beautiful. But this is not the product consumers recognize. Not yet. The gelatin block must still be converted into a form that can be stored, transported, and prepared instantly. Massive hydraulic systems push the gelatin through perforated metal plates. Thousands of tiny openings transform the gelatin into long strands. Like noodles, thin ribbons of pure gelatin emerge continuously, meter after meter. The strands fall onto moving conveyor belts. The next stage begins immediately, drying. Powerful streams of sterile hot air circulate through enormous drying tunnels. The moisture slowly disappears. The gelatin loses water while preserving its structure. Hour after hour, the strands become lighter, harder, more brittle, until finally, almost all moisture is gone. What remains is concentrated gelatin, pure, stable, ready for processing. The dried strands move toward industrial grinders. Massive rotating blades crush the material into a fine powder. The transformation is complete. Bones, skin, connective tissue have become powdered gelatin. But one final transformation still remains, because consumers do not buy plain gelatin. They buy flavor, color, and experience. The powder enters large stainless steel mixing systems. This is where royal gelatin receives its identity. Sugar is added first, not only for sweetness, but also to improve texture and shelf life. Next come acidity regulators. Ingredients such as citric acid help create a balanced flavor profile. Then come the flavors: strawberry, lemon, orange, pineapple. Each recipe carefully calibrated, each batch identical to the last. Consistency is everything. Now the color arrives: natural extracts or food-grade colorants, depending on the product being manufactured. Bright reds, vibrant yellows, deep oranges, colors designed to create an immediate emotional connection with consumers. The transformation is striking. What began as a neutral protein powder now looks and smells like the dessert millions recognize instantly. The final ingredients are stabilizers and anti-caking agents, invisible components that prevent clumping during storage and help the powder dissolve smoothly at home. The formulation is complete. Every ingredient has a purpose. Every gram has been measured. Every batch has been tested. The finished powder now moves toward packaging. Automated systems divide the gelatin into precise portions. The familiar supermarket packets, industrial containers, family-sized packages. Every format follows the same process: precision filling, automated sealing, quality inspection. Every package receives a production code, an expiration date, and complete traceability. If necessary, every packet can be traced back to the exact production batch. Nothing is left to chance. Robotic systems organize the finished products into cartons. Cartons become pallets. Pallets become shipments. Within hours, trucks begin leaving the factory. Thousands of boxes, millions of servings. heading towards supermarkets, restaurants, pharmacies, and stores around the world. The journey is almost complete. Days later, a customer picks up a small packet from a shelf, a simple purchase, a simple dessert, but behind that packet lies an extraordinary story. A story of chemistry, engineering, biology, and industrial precision. What began as animal bones and skin has become one of the world's most versatile ingredients, found in desserts, medicines, supplements, cosmetics, and countless products we use every day. Most people will never see the process. They will never see the factories, the extraction tanks, the filtration systems, or the miles of production lines. They will only see the final result: a colorful dessert, a pharmaceutical capsule, a nutritional supplement, and perhaps they will never imagine where it all began. So, would you still eat gelatin if you knew how it is made? Because now you do.